A junior developer and a senior developer get the exact same bug report. The junior developer starts typing a fix in 10 seconds. The senior developer sits back, reads the error twice, traces it through 3 files, and only then writes 1 line of code. Guess whose fix survives the next deploy? Most AI coding assistants act like that junior developer. They answer instantly, they sound confident, and half the time they're solving the wrong problem. Today, I'm going to show you how to turn on the senior developer version of Grok right inside VS Code, so it actually thinks before it touches your code. You'll see it catch a bug that a normal autocomplete would have shipped straight to production. And later, I'll show you a second bug that's even sneakier than the first one. Before we go further, tap like and leave a comment with your current VS Code setup. It helps me know what to cover next, and it tells the algorithm this is worth showing to more developers like you. Let's start with why this even matters, because if you skip this part, the rest of the video is just button clicking. Every fast AI coding model, including the quick versions of Grok, is built to answer in milliseconds. Speed is great for autocomplete. Speed is terrible for anything that involves logic, edge cases, or a bug that only shows up under specific conditions. Grok has a separate mode called reasoning, sometimes shown as a thinking trace, where the model slows down on purpose. It writes out its own reasoning step by step before it gives you the final answer. Think of it as the difference between someone blurting out a guess and someone working through the problem on a whiteboard first. You don't just get an answer, you get the thinking that produced it, which means you can catch a wrong assumption before it becomes broken code. Here's the part almost nobody explains properly. Reasoning isn't one fixed thing you turn on or off. It's a dial, with several stops along the way, and the model actually behaves differently at each one. At the lowest stop, it barely pauses. It just double-checks the obvious. At the highest stop, it can branch out, consider 2 or 3 different explanations for the same bug, rule some of them out, and only commit to an answer once it's fairly confident. That's exactly what we're setting up, and once you see it work on a real bug, you won't want to code without it again. Step 1 is getting the right extension, and this is where a lot of people waste time installing the wrong thing.
Open the Extensions panel in VS Code, the icon with 4 squares on the left sidebar, or press Ctrl-Shift-X on Windows and Linux, Command-Shift-X on a Mac. Search for the Community Grok Build extension for VS Code. There are a few similar-sounding extensions in the marketplace, so look for the one that specifically mentions running the official Grok coding agent with native diff previews and permission cards, not just a basic chat window bolted on. It's free, it's open source, and it runs that agent inside a sidebar instead of a separate browser tab. Click Install. Once it's done, open the sidebar with Control-Semicolon or Command-Semicolon on a Mac. A setup wizard appears and walks you through signing in. And if the underlying command line tool isn't on your machine yet, it installs that for you automatically. You don't need to touch a terminal for any of this, which is exactly why this setup takes about 5 minutes instead of an afternoon. Step 2 is where the actual thinking gets switched on, and this is the part most tutorials skip completely. In the sidebar, open the gear icon in the bottom toolbar. You'll see a setting called Reasoning Effort. This is the dial that controls how hard the model thinks before it responds. The options usually run from none up through minimal, low, medium, high, and an extended setting for the hardest problems. Set this to none, and you're basically back to fast, shallow answers, no different from a basic autocomplete with a chat window bolted on. Set it to medium or high, and the model pauses, works through the logic internally, and only then writes its response. For most day-to-day coding, medium is the sweet spot. Save the highest setting for the problems that have already beaten you twice. Before writing code that assumes a shape it never confirmed, this is the pattern you want to internalize. Reasoning doesn't just make answers longer, it makes the model check its own assumptions against your actual code, instead of against a generic textbook example. Now, here's a mistake I want you to watch for, because almost everyone makes it in their first week. People discover reasoning effort, set it to the highest level, and leave it there for everything, including questions like renaming a variable or writing a basic loop. Don't do that. Every extra second of thinking uses more tokens. And if you're on the API pricing tier instead of the bundled plan, that adds up fast on trivial requests. Worse, it slows down your workflow for no benefit, because a simple task doesn't need a whiteboard session. The model picker and the reasoning effort setting both work live, mid-conversation. So the right habit is to match the setting to the problem. Quick edit, rename, formatting question, turn reasoning down or off. Anything involving state, timing, security, or a bug you can't reproduce reliably, turn it up. That single habit will save you more money and more time than almost anything else in this video. There's a second mistake that's less obvious, and it trips up people who've already gotten comfortable with the first fix. Once developers learn to trust the reasoning trace, some of them stop reading it. They see the word thinking appear, they assume it's doing its job, and they scroll straight past the reasoning to the final code.
Right next to that setting is a toggle called Show Thinking Traces. Turn this on. This is what actually lets you watch the reasoning happen instead of just trusting a black box. You'll see a line that says Thinking, followed by the model's internal notes. What it assumes about your code, what it's ruling out, and why it's choosing one approach over another. While you're in that gear menu, there's a second setting worth knowing about, which is the model picker itself. Grok isn't one single model, it's a small family, and they're not interchangeable. Some are built for raw speed on simple completions, some are built specifically for agentic coding tasks, like editing multiple files in sequence, and some are the deeper reasoning versions, meant for exactly the kind of thinking mode we're setting up. If you're using an API key instead of the bundled plan, you'll see the wider model family in that picker, and it's worth spending 30 seconds picking the one actually meant for reasoning instead of assuming reasoning effort alone will fix a model that wasn't built for it. Now, let's actually use this on something real, because settings on a screen don't mean anything until you watch them catch a bug. Say you've got a function that fetches user data and caches it for 5 minutes, but every so often, users are seeing stale data even after the cache should have expired. You paste the function into the chat and ask what's causing the stale reads. With reasoning turned off, a fast model will usually spot the obvious thing, maybe suggest you shorten the cache time and move on. With reasoning turned on, you'll watch it work differently. It reads the expiration check, notices the timestamp comparison uses less than instead of less than or equal to, and traces what happens at the exact millisecond the cache should expire. Then it goes further, because a good reasoning process doesn't stop at the first plausible answer. It checks whether multiple requests could be hitting that function at the same time, before the first one finishes refreshing the cache. That's a waste condition, and it's the kind of bug that only shows up under load, which is exactly why it survives code review and breaks in production. A fast answer would have handed you a one-line fix for the timestamp and called it solved. The reasoning trace catches both problems, because it actually walks through what happens in different orders of execution, instead of pattern matching to the nearest familiar bug. That gap between those two answers is the entire reason this setting exists. Let's push it one step further with a second example, because the first one was about timing, and this one is about something almost every developer has shipped by accident at least once. Imagine you ask it to add a search feature that filters a list of products by name, and you want it to also search by category because a teammate requested that after the first version already shipped. A fast answer typically bolts on a second condition, checking the category field alongside the name field, and it looks correct in a quick test. With reasoning turned on and set to medium or higher, watch what happens before it writes a single line. It walks through what happens when category is missing on some products, because your data was migrated from an older system where that field didn't always exist. It notices that an unguarded check against a missing field would either throw an error or silently exclude valid products from every search, depending on how your data layer is written, and it flags that difference explicitly instead of picking one silently. That's not a guess. That's the model tracing through your actual data shape. Session that's touched more than 5 or 6 files as a candidate for a compact, even if the indicator hasn't hit its limit yet. So here's the golden move that ties all of this together, and it's the one thing I want you to actually change in your workflow starting today. Don't ask Grok to fix your bug. Ask it to explain the bug first, with reasoning turned on, and read the thinking trace before you approve any code change. That single shift Reading the reasoning instead of skipping straight to the diff is what separates people who ship a quick patch from people who ship a fix that actually holds up. I test new AI coding setups every single week, comparing the free options against the paid ones so you don't waste money finding out which is which. If a new free method comes out that beats what we just covered, you'll see it here first. Go set your reasoning effort to medium right now. Turn on thinking traces and try it on the messiest function in your current project. Drop what it finds in the comments. I read every one, and I'll pull the best examples into the next video. That defeats half the point. The value isn't just that it thought harder. The value is that you get to see what it assumed. And assumptions are exactly where these tools get things wrong. If the trace assumes your database is never queried from more than one place, or assumes a field is always present when your actual data says otherwise, you want to catch that in the trace, not 3 days later in a support ticket. Reading the reasoning takes maybe 15 extra seconds. Skipping it is how a fixed bug turns into a different bug with your name on the commit. Let's talk about one more setting that changes how this actually feels to use day to day, and it's the permission system. When the model wants to edit a file or run a command, it doesn't just do it silently. It reads as a card, showing you the proposed change as a native diff, with the full file for context and the changed lines highlighted. You get 3 choices: allow once, always allow for this type of action, or reject. I'd recommend starting with allow once for the first few sessions, until you get a feel for how it behaves on your codebase. Once you trust it on routine actions like formatting or adding a test file, switch those specific actions to always allow, and keep anything that touches your database, your environment variables, or your deployment scripts on manual approval. This is also where the reasoning trace pays for itself a second time, because you can read the model's own explanation for why it's making a change before you approve it, instead of approving blind and hoping. One more practical thing before we wrap up the core setup, and it's something that only shows up after you've been using this for a while, so I'd rather you hear it now than discover it the hard way. If you're running long agentic sessions where the model is reading multiple files, planning, and editing over several turns, watch the context usage indicator in the sidebar. It's shown as a small donut chart tracking how much of the context window is filled. Long sessions reread a lot of surrounding code, and once that indicator gets close to full, responses get slower and occasionally less accurate because the model is juggling more information at once, including earlier reasoning it already worked through. When you see it climbing, use the compact command in the chat to condense the session history before continuing. That one habit keeps long debugging sessions fast, even after an hour of back and forth, and it stops the reasoning quality from quietly degrading in the middle of a task you haven't finished yet. If you want a rule of thumb, treat any